Hello, and today we're going to learn how to write functions giving situations. Here's an example of a couple of functions that are, two of them are pretty common, and then the other one is just kind of like a linear function. Before we start writing them based on situations, let's figure out what the definition of a function is. So a function is a relationship between an independent variable, we call that the input, and a dependent variable, we call that the output, and that relationship is that for every input value there is only one output value. You cannot have more than one output for a given input. So what does it mean? Well, here are some examples of two variables that we would call a function. So if you were to take the input, meaning the radius of a circle, and the output being the circumference of a circle, that would be a function. For every value you can put in for the radius, you would only get one value for the circumference. Meaning if I put in a radius of 2 inches, I'm only going to get 4 pi for my circumference. There's no other circumference I can get with an input of 2 inches. Social Security number, if you input a Social Security number into a computer, there should only be one name that pops up. So the relationship between an input of a Social Security number and an output of the name of a person should be a function. Likewise, if you input a license number into a computer, it could potentially give you the birth date of the person. That is a function because you should not, or there should not exist more than one birth date on any one license. That doesn't make sense. Some examples of things that are not functions. Just take the second one here and reverse it. So you put in the name of a person into a computer database, and the output is all of the Social Security numbers attached to that name. Now, certainly each one person only has one Social Security number, but if I put in a name like John Smith into a computer, and it calculates all of the Social Security numbers that have John Smith on their attached to them, there's going to be many. So therefore, an input of a name and an output of a Social Security number is not a function, because putting in a name, several people have the same name. So you will get several different Social Security numbers popping up with one given name. Likewise, the third one, if you reverse them. So I put in a birth date, and I want my output to be all of the license numbers that have that birth date. There's going to be many. So reversing the input and the output of the second and the third one result in non-functions. The first one actually is a function. If I put in the circumference of a circle, there's only one radius that could give me that circumference. So therefore, that would be a function whether this is the input and this is the output, or vice versa. All right, let's take a look at what a function looks like written out. So we're going to use the equation area of a circle equals pi times the radius squared for this demonstration. This is the equation written in function notation. Notice it looks very similar. The only really addition is that it's got this parenthesis r here. By the way, this is read as a of r. So that would be how we read this. It would be a of r equals pi r squared. And what we're saying when we say a of r is that the area is dependent on the radius. So the dependent variable, area in this case, is actually a of r. And the independent variable, or the input, is r, or the radius. Okay? That's really the only difference in how a function looks. There's other things that come along later, which we will discuss in a different video. And then the actual relationship that they share, in other words, what you have to do to the input to get the output, that's called the argument. Alrighty, let's take a look at writing these things based off of situations. Alright, let's look at the situation where if pencils cost 25 cents, what would be the function for the total cost when buying P pencils? So we have two variables, total cost and the number of pencils that we're going to buy. The first thing we should identify is what depends on what. Does the cost depend on the pencils, the number of pencils, or does the number of pencils depend on the cost? And hopefully you come up with the cost depends on the number of pencils. So my output, my dependent variable, is cost, and it depends on the number of pencils. The input, the independent variable, would be just the number of pencils. Okay, and then the actual function would be what? The cost, C of P, would equal, what would the total cost be? If I'm buying P pencils and they're each 25 cents, it'd be whatever 25 cents is times, it would be 25 cents times whatever the number of pencils I buy is. So here is the function for the given situation. Okay, let's look at another one. Write a function for the volume of a cube. All right, so how do we find the volume of a cube? Well, we need the side length, and then we cube it. Okay, so we have two variables, volume and side. What depends on what? Does the side length depend on the volume, or does the volume depend on the side length? And generally, it's agreed upon that the volume depends on the side length. So my output, my dependent variable is volume, which depends on the side length. And the input would be the side length. Okay. So what is the equation? Well, my volume, which depends on the side length, is equal to my side length cubed. And that would be the function. Let's look at one more. So if I drive 55 miles an hour on the Merritt Parkway, what would be a function for the total distance I would travel in h hours? All right, so we're looking at two variables here. We're looking at distance traveled and time traveled. What depends on what? Does the distance I travel depend on how long I drive, or does how long I drive depend on the distance I drive? Well, if it says I'm driving steady 55 and is asking you for the distance based on the number of hours, it's actually kind of hinting at it the way they sent it up in here. They want a function for distance, so they're telling you distance is what is dependent. Distance depends on how many hours you drive. So let's write that out. The output is distance, which depends on how many hours I drive. Okay? And the input would be the number of hours I drive. The equation, do you remember d equals rt? Distance equals rate times time. So the distance, which depends on the number of hours I drive, is equal to the rate is 55 miles an hour, times the number of hours I drive. So there would be a function for this situation. Okay? So it's no different than writing the equation for a situation. The only real difference is that we include with the dependent variable, or the output, we include with it the variable that it depends on. And you're going to see where that comes into play in the future video. But for right now, you now know how to write a function. Congratulations.